In TCP IP model, a communication is summarized into 4 different layers, which as you see are network access layer from bottom to top, network access layer, internet layer, transport layer, and application layer. Let's say that we have 2 devices and a connection has been established between them, or they want to send and receive packets to each other. And let's say in the application layer, application protocol like HTTP wants to send data, for example, a HTTP request to a web server. So based on the specification of this protocol, the data will be delivered to the one of the 2 main protocols in the transport layer, which are TCP or UDP. In the transport layer, the TCP or UDP, for example, let's say TCP in this example, will add the related header to the data, and then it will deliver the packet to the next lower layer, which is the internet layer. In the internet layer, the 2 main protocols are IPv4 or IPv6. In this layer, the IP protocol module looks at the whole TCP and the TCP header and data as a one whole packet, and then it will add the IP header on it, or it will encapsulate the whole packet by its header, and then it will deliver this whole packet to its next lower layer, which is the network access layer. In the next network access layer, a protocol like Ethernet, it will encapsulate the whole packet by its header. What it means is that, like the other layers, it will look at the IP header, the TCP header, and the data header all as its own datagram, and then it will add the Ethernet header. The network interface card will convert this whole packet into the related bits and send it through the wire or any other medium. On the other side, the network access layer looks at the Ethernet header, and based on the information in the fields of the Ethernet header, it sees that this packet is destined to the network interface card, the MAC address. It sees that it is the true packet, so it won't drop it, and it will deliver it to the next higher layer. Again, based on the information on this field, it knows which protocol of the higher layer it should deliver this packet to. In this case, it is let's say IPv4. In the internet layer, the IPv4 protocol module again looks at the IP header that the corresponding IP layer on the source side has added, and then by looking at the different fields in the IP, it makes sure, for example, by checking the header checksum, that the integrity of this packet is intact, and also it looks at another fields and it sees that this IP, this packet should be delivered to the TCP protocol on the next higher layer. So it will strip out the IP header and deliver it to the TCP protocol module in the next higher layer. The transport layer again do the exact thing as the lower layer. It looks at the header, at the TCP header and different fields, and then it strip out the TCP after checking all the fields on the TCP header, and deliver the data to the application layer, which in this example is the HTTP. So if we want to talk, as you saw, when a communication is taken place between 2 devices, it looks like that every protocol on each side are talking to each other directly. On the first side, the process will go from top to bottom. The data will go from the application layer, will be delivered to the transport layer, then internet layer, then network access layer, and each layer will add a header to the data, so it will be more complete, and then it will be converted to bits and bytes and will travel through the medium. And on the other side, every layer will just look at the header that the corresponding layer on the first side has added. For example, the network access layer doesn't care what the internet layer has added to the packet. It only cares that what the network access layer protocol, the Ethernet in this example, has added to the packet. And then it will strip out the corresponding header and send and deliver this packet to the top of the hierarchy. In the next lecture, we will expand all the layers field by field and we'll talk more about how this layer, how this protocol add the related fields and headers to the packet.